We've spoken at length in this course about the utility of technology tools in problem solving. Sometimes technology tools just appear in the middle of the problem. For example, we get to a complex calculation, we plug it into a calculator. Or we'd like to see a visualization of something, so we make a graph. Sometimes, however, technology tools are needed from the outset of the problem-solving process, and it's not always evident which technology tool is best used for a given problem. One of the skills that you'll learn as you work on solving problems is to weigh the pros and cons of each tool at the outset so that you can choose the appropriate tool and not find halfway through the problems that you wish you'd use something else. This is just as true for technology tools as you've probably experienced is true for analytical tools. So in this video, we're going to graph a function, a simple function, using the TI-83 graphing calculator made by Texas Instruments and Excel, and we'll weigh the pros and cons of each. Take a look at this TI-83 graphing calculator. You may own one of these already, so it may be familiar to you. You can see that there are a number of buttons on the calculator. There are numbers, function buttons, such as plus, minus, multiplication, division, functions for things like trigonometric functions, sine, cosine, and tangent, as well as exponentials and logarithms, a number of different things that we've used. Here in the top row of buttons, you have your function graphing tools. This is where you use the graphing calculator functions. So in this module, we're going to visualize y equals x squared minus 4x. And the first step is to click on the y equals button and to enter the function using the keypad. When you enter the function and choose to graph by clicking graph from the y equals menu, the function will be displayed in the standard 10 by 10 window. Now 10 by 10 is a little misleading. It's actually a 20 by 20 window with a domain of 20 from negative 10 to positive 10 and a range of 20 from negative 10 to positive 10. So we can see our parabolic function here. The function is shifted over by 2 and down by 4. Suppose that you didn't want to see the function in such a small window. Perhaps you want to zoom in on the vertex of the function. In this case, you would click on the window button, where you could enter the minimum and maximum x values, as well as the minimum and maximum y values, the scale, for example, whether you want the hash marks on the x and y axes to be at 1, 2, 3, 4, or 5. And then you can click window again to return to the graph. We've adjusted our window to a negative 1 by 5. This gives us a domain from negative 1 to 5, and our range will remain negative 10 to positive 10. We can see that our function looks much different, and we can zoom in on the vertex much more effectively. It's much clearer now that the vertex is at x equals 2, y equals negative 4. Now clicking on our calc button, or rather second and calc button, we can make some calculations on our function. We can find things like the value of a function at a given x value, or f of x for that value. We can find the 0, or the x value for which the function is equal to 0, the y-intercept, or rather the x-intercept, the minimum and maximum values of the function over the course of the domain and range, the y-intersect value, as well as dy dx, which is the rate of the change of the slope of the function. This would be the instantaneous rate of change of the function. So a number of things that we can quickly calculate with this TI-83 graphing calculator to understand the properties of our function or relation. Now let's take a look at Excel. We can't directly graph a parabola in Excel. There's no place to enter an equation and have a full parabola calculated over the course of the entire infinite range. So in order to set the range in Excel, we create two columns, one for x and one for y, and then we set the initial value of the range, the smallest value we want to look at. Perhaps it'll be equal to 0, and then our next value will be set equal to the first value. In this case, we've chosen negative 0.1. And we add some incremental amount, depending on the resolution we want. If we want a high resolution, this increment will be smaller. If we want a low resolution, this increment can be larger. We'll then extend this calculation down several rows. So we can see that the increment we're moving is in the plus 0.1 direction, starting at -5 and heading upward. For our y column, we'll set y equal to the corresponding value of x placed into the function. So remember that our function was x squared minus 4x. So in this case, y for a given value of x is equal to that value of x squared minus 4 times the value. So we'll simply set our y cell equal to the function value and extend this down the course of the column. This extension looks like this. You can see for our value of x is equal to -5, y is equal to 45. And then we can very quickly graph this value. We can set the domain and range to whatever we wish to zoom in, but we don't have infinite resolution. Remember that at some point, if we were to say set this axis value equal to 0.01, we would simply be looking at a straight line because we don't have infinite resolution to zoom in. Although this is certainly a problem compared to the graphing calculator, we do have the benefit of being able to make calculations for whatever values of x's and y we want. We can quickly scan the function by selecting the function and looking at the value at a given point. So in this case, we're zoomed in on the point x is equal to -3.2, and we can get the corresponding y value by looking at the graph. If we want a value that's not in our initial domain, we can also very easily set up a calculation field so that we can quickly calculate values that we want. And we can reset our domain and range or change the resolution to look at the part of the function of interest to us. So while Excel provides less resolution and less exactness in the calculations, it also provides greater flexibility. Which you would choose to solve a particular problem depends on your needs at the time